Hello everyone, welcome back to our channel. I hope you are doing extremely well. So today we are going to solve one of the most important interview asked question from the Leetcode. So let's try to understand first what is the question actually. So the question is search a 2D matrix. So what is the question is exactly? So we have given a matrix, 2D matrix, and you are given an m cross n integer matrix with the following two properties. Each row is sorted in non-determining order. The first integer of each row is greater than the last integer of the previous row. So given an integer target, we have to return true if the target is in the matrix, or if it is not, then we have to return false as an answer. And we must write the solution in an order of log into m cross n time complexity. So let's try to understand the question first. So we have given one 2D matrix and we have to find out the target value in this matrix. Let's understand from this example. So in this example, we have a given 2D matrix and we have to find the target 3. So see here, 3 is present at row 0 and column 1. So yes, 3 is present. So as the answer, we have written true. See the example 2. In this example, we have also given an integer 2D matrix where the target is 13. But 13 is not present in anywhere in this 2D array matrix, so the answer is false. So let's understand the question with an example. So let's come to see clearly with this example. So how can we solve? How can we find out a target in this 2D array? So the first brute force approach definitely which comes in mind is that what can we do? We will traverse each row and we will check that is the target is present within the specific row or not. Let's assume that the target here in this case is 3. So what we'll do, we will simply traverse from the first row. We'll start the traversal of the from the first row, and we will check is 1 is equal to 3. No, it's not. Is 3 is equal to 3? Yes, we got our target here. So we will simply here return true as a result. Let's take another example, and we need to find out uh, the target value as 34. So in this case, what we'll do here, let's try to understand with this example. We need to find out the target as 34. We will start the traversal from the first row. We'll check is the first row is 1 is equal to 34? No, it is not. Is 3 is equal to 34? No, it is not. Is the 5 is equal to 34? No, it is not. Is 7 is equal to 34? No, it is not. When we haven't got the 30 target value at the first row, so we will start the traversal from the second row. Now we'll check here. Is the 10 is equal to 34? No, it is not. Is 11 is equal to 34? No. Is 16 is equal to 34? No, it is not. Is this one? No. Again, we will start the traversal at the third row. Now we will check. Is 23 is equal to 34? No, it is not. Is 30 is equal to 34? No. Is 34 is equal to the target? Yes, it is. So now we got our target here, which is 34. So in this case, we will simply return true as a result. So let's understand the algorithm. How can we solve it? So what is the brute force approach for that? So I have clearly written the algorithm in a step by step way. The first we have to store we have to take two pointer n and m. where you can store the n will store the number of rows and m will store the number of columns. We have to execute the loop through rows. Iterate each row from 0 to n minus 1. After that, we have to loop through columns. Iterate each column from the 0 to m minus 1, right? And then we have to check the data. If the current element matrix, and we know what we can do, we just need to iterate the each row, and whenever we got the target, then in that case we will return true. If it is not, then we will return false as a result. So let's try to code. Yeah, for the save the time, I have already written the code for this approach. So see here, uh, I will explain each line of the code so that you can understand easily. So I have taken two pointer n and m. N will represent the number of row and m will represent the number of column in this 2D matrix. So I will add this for loop will execute all the rows in this 2D matrix, and this will execute the number of columns. So at the first, we'll check if the matrix row is greater than target. In that case, we will break. Why? Because as the each row is sorted. So if some place, like let's see here with the example, see here we need to find out the target. If let's assume that the target is let's assume that the target value is 16, right? Sorry, let's assume that the target value is 4. Yeah, so let's see one example. Let's assume that the target value is 9, right? The target is 9, but 9 is not present in this loop. So whenever we got come here, so as the 10 is greater than 9, it means that this entire row will contain all the elements which are greater than 9, because at the first at here we got the value which is already greater than 9, and as the row is sorted, so definitely all the remaining element will definitely be greater than 9. So will not cheat this of will not cheat this row will come to iterate and cheat the next row. So this way, I hope it's clear to you that why I have written this one. If the current cell is equal target, then definitely we will return true as the answer. Got it? At the end, if the target is not present in the entire matrix, so we will simply return false as the answer. So let's talk about the time complexity of this approach. So as we are using two nested loop, as we are using two nested loop, so what we can do here, so the time complexity will be due to two nested loop. The outer loop will execute number of row time, which is n, and the inner for each row inner loop will execute m time. The total time complexity is order of n into m, right? So this is all about the time complexity of this approach. So can we optimize this? Yeah, definitely we have to optimize it, because in the interview they will ask us to optimize this approach. So as the each row is sorted, so when the row is sorted, and we have to find out a specific element in the sorted array, so definitely what will be the use? Binary search is the more efficient to solve this problem. So definitely binary search we can use here. So let's understand how binary search we can implement in this 2D matrix. So let's try to understand how we can implement the binary search in this 2D matrix. So as what we can do here, definitely we need to iterate each and every row. So we can reduce the searching of each row as the each row is already sorted. So what we can do here, we simply loop through the rows, and for the each row we will will implement the binary search. Initialize the low as 0 and high will point to the last column, and we will execute the binary search while low less than equal to high. After that, we will calculate the mid low plus high divided by 2. And if the mid value is equal to the target, then we will return true. If not, then we will update the window search size. If the mid value is greater than target, it means that the target element might be present at the left side from the mid. So we'll move the left to mid -1. If it is not, if the mid value is less than or equal to target, it means that the target will definitely present at the right side of the mid. So we'll update the low as mid plus 1. After that, after all row checked, target not found, then we will return false as a result. Yeah, so this is the code for the binary search implementation. That yes, this is the function. I have initialized the n and m, number of row and number of column. Then I have exit the loop. It will execute all the rows. After that, for if while searching on the row, we have implemented the binary search. If we have checked the entire row and if we haven't got the target, then in that case the target will not be present in the 2D matrix. So in that case, we will just simply return false as a result. So if I talk about the time complexity, so to solve this approach, the time complexity is order of the time complexity is as we are iterating all the row, so the number of row which is n into, as we are not iterating the column, what we are doing here, we are just implementing the binary search. We are searching using binary search. So the time complexity is log m to search a specific row. So the total time complexity is order of n log m, which is definitely be an optimal solution for this problem. So I hope that this solution and approach helps you a lot to understand the problem. So that's it for today video. We will come back with another important video of the DSS series. Thank you so much for watching the video. Till then, bye bye. Take care.